Okay. So, okay, so this is 2-57. So the question says, you aim to establish a perpetuity wherein money will be withdrawn every other compounding period. Okay, all right, so we'll withdraw every other period. That's important. For example, you might invest, the investment might compound every 6 months, but funds are withdrawn once a year. If our dollars are withdrawn at a rate, so we've got our dollars at a rate little r percent, find the formula for the present value of the perpetuity. Present value of the perpetuity. Okay, so first things first. Okay, Curdy, I see it. And Theodora, I got yours as well. Yeah. Okay. So everyone, what's the first thing that we do? Basically, anytime we have a financial math problem, what's the first thing? Timeline, exactly. Timeline. Now, I guess there is a little bit ambiguity into this question. For example, might investor be compounded, but funds are withdrawn once a year. So the way I'm reading this question, and if you put a payment right at the very beginning, I wouldn't hold it against you. But the way I'm reading this question is that the first withdrawal isn't made until after the first two compounding periods. All right, so R, etc. Okay, so does everyone agree with my timeline? Timeline makes sense, right? We're compounding twice as often as our payments. I've chosen to interpret this question as having the payment at the end of the period, but that's maybe a little bit up for, this question is from a time when we weren't worried about simultaneous events and compounding things. So this is the setup, but trust me that if I were to give you this question, I would say something like the first payment occurs at the end of the first year, and compounding interest is at the beginning of the 6th month or something like that, just so that we don't have to worry about this stupid simultaneity thing, right? So Collins, read submitting to CrowdMark so that you, and that will tell you what to do in terms of, yeah, it's fine. Let me answer that a little bit later. I couldn't get a Toronto email. My only email link to Quirkus is not. I mean, like there will never be a situation in which you lose all of your marks. So I'm going to sync, and then you'll have the ability to merge. Okay. But like, even if you're in another class that's using CrowdMark, you can log in there and should be able to sync the accounts there. So if you're like in econ or management and they're using CrowdMark, log in with your Toronto there and merge it with your whatever Gmail that you sync through this class. Okay, so let's start pulling these payments R. Let's start pulling them back to the future, or sorry, back to the present. So this payment R is going to be worth what? What is the present value of this payment? And again, this payment is happening. Oh shoot. And to the -1 though, right, Curdy? But yes, I'm trying to think about whether there should be. No, I guess it is. Yeah, the way it's set up, this is what it is. So this is going to be R times 1 plus R to the -1, right? Okay, this payment is going to be what? -3, exactly. And then this payment, and probably after this one, we get our pattern. -5, exactly. Okay, so the present value of this perpetuity is R times 1 plus R to -1. And of course, this goes forever, but I think we see the pattern, right? That the exponents are just the negative odd numbers. Plus dot, dot, dot. Okay, so if we want to write this in sigma notation, how would we write it? All right, so what's the pattern first of all? Anyone? What's the common ratio? Right, if you divide one term by the previous term, what do you get left over? Close. Okay. Not Curdy, I think you went the wrong way. So you don't want to remember, everyone. So to get the common ratio, we're going to take any term and divide it by the previous one. So we're going to do 1 plus r to the negative 5 divided by r times 1 plus r to the negative 3. So that gives me, Sylvia, is that a complex number in your exponent? Oh, no. Oh, I see. You're giving me the, yeah, Sylvia, you're right. Sorry, I misinterpreted your eyes, but yeah, yours is right. And Alessandro, right, but negative number, right? 1 plus r to the negative 2. Because if we do negative 5 minus negative 3, that would give us negative 2, right? So there's now a couple ways of doing this. Sylvia, you're absolutely right. I'm going to kind of stick with what we have here. So if we do it this way, then our first term is r times 1 plus r to the negative 1. And then we have, right, so there's no k's there. And then we have our common ratio like this. Okay, so what's the first value of k? What value of k makes this equal to this? 0. Okay, great. And then it goes to infinity, right? And I can pull out that r times 1 plus r to the negative 1, just because there's no k's in it. Right? And then I can just plug this into my formula. So r times 1 plus r to the negative 1, 1 over 1 minus 1 plus r to the negative 2. Why is it 0? So what we're looking for is the value of k. So y k is equal to 0. So we want right, because we want it to be equal to the very first term. So this was a direct message for people wondering like where this question came from. And so what we want is that the thing inside the sum has to be equal to the first term. So we want the value of k for which that's true. And if we look at this, we say, look, these two things are already equal. So this number here has to be equal to 1. And the way that we make that equal to 1 is by setting k is equal to 0, right? So that's why k equals 0 is the first term. Okay, makes sense? Now, Sylvia very cleverly realized that instead of doing this, common ratio thing, she figured out how to go right to the final answer. To the negative, what did you say? Let me just check what you wrote down. Negative 1 plus 2i, like so, from I equals what to infinity? Okay, so if we use Sylvia's technique here, we need r times 1 plus r to the negative 1 plus 2i to be r times 1 plus r to the negative 1. So what's the value of I which makes this true? Careful. Plug I into that equation. Oh, no, sorry. What am I thinking? Of course, you're right. So you would get 0. But Sylvia, now the only thing I'm a little bit worried about is you said negative 1 plus 2i. Is that right? So if I is equal to 1, what's the next number? Like, what's the next exponent? There's no difference, Jeremiah. They're just dummy variables. We could have called it k. I used I just because that's what Sylvia used. Right. So Sylvia, see the problem? So if I set I is equal to 1, the exponent is now plus 1, and then plus 3, and then plus 5. Oh, right, there you go. So this actually has to be minus 2i. Okay. And I equals 0 still works, but it has to be negative 1 minus 2i. right? So this, we actually want this to be minus like that. Perfect, perfect. Okay, everyone's good? So part B says generalize A by compounding K times more frequently. So in this case, what we did is we compounded twice as much as we had our deposits. And this is generalize this to K times as much. So you can imagine the only thing that's going to change, you'll still start at, you'll start at a slightly different number, but now you have K things in here, right? And so you can work that out there. Hopefully, this is starting to get a little bit more abstract there, but if you want, you can kind of continue into this problem. Oh no, sorry, I'm reading 58. Suppose P1 is the present value of an annuity whose compounding term corresponds with the withdrawal term. Let P2 be the present value of the situation described above, where in the, which number should be larger? Oh, B is a great question. Okay, so 257B says P1, for P1, we have compounding equals deposit, right? That's the present value of a perpetuity whose compounding periods and deposit periods coincide. If P2 is the situation above, so we have double compounding, which number is bigger, P1 or P2? Okay. Wait, what did I say again? Which one is bigger? Yeah, so here, let me say, is P1 bigger than P2 or is it less than P2? That'll be more clear. P1 is less than P2, okay. Why? Assuming they're the same rate, right? Use the same interest rate. Okay, but remember I'm computing present value. Right, Jack, you kind of hit it on the head, right? So Curdy, you have the right idea. Compounding means more if you're going into the future, but because it means more when you're going to the future, when you're bringing it into the past, it actually means less, right? Because you're discounting each payment by a bigger number. Does that make sense? Right? So remember, as you move, like the bigger rate, as you move forward in time, the more you compound, the bigger the number. And so vice versa, when you're pulling back to the present, the more compounding periods will actually give you a smaller number, right? So in fact, P2 is smaller than P1. And then C is to actually just plug in numbers. So a $5,000 annual scholarship is to be established off of Office of Advancement figures it can get an APR of 3%, compounding semi-annually. Determine the amount. So we just take this formula, plug in R equals 5,000, and little r is APR 3% compounding semi-monthly, so 0.03 divided by 2. And you just plug these numbers into that equation, and that's C. Okay, so are there any outstanding questions about this one? This is a great question. Thank you for asking it, because yeah, it's again kind of one of these slightly weird things. We can't just use the perpetuity formula. We kind of have to rederive it. But again, we've kind of done this thing about moving money forward and backwards through the timeline. We've done that a million times, right? So hopefully we just have done enough practice with it that we're okay with it. And if you can, and if you were comfortable with this, I'm certain that there's nothing I could throw at you that would make your life too bad. Okay. All right. If that's good, then what I'm going to do, I'm going to do the financial quiz question 5, because I was asked to do that. And Curdy, I need to make sure I download your questions before they disappear deep within the chat. Okay, so let me pull up question 5 of the finance quiz. And let me just see, where is it? Quizzes, finance concept quiz. Question 2, question 3, question 4, question 5. Oh, yuck. Okay. Oh, question 5 is a bond question, though. I wouldn't worry too much. I forgot who asked about it. Question 5 is a bond question, though. So, we're not going to ask you about bonds. I can still do it if you want. It's just it's not something you're expected to know. So there are words in here that you don't know, right? Like coupon and stuff like that. Okay, I see you, Victoria. So whoever asked finance concept quiz question 5, I'm sorry, I don't remember who you are. Do you want me to kind of go through it anyway, or are you comfortable with like why that you don't need to know this stuff? Maybe 6 instead. I like it. You kind of like pivot it and do a different one. Sure. So 6 instead says, here, maybe I'll share my screen just so everyone can see it. And desktop here. Okay. So here is the question. I just want to make sure everyone can see it. Okay. So I'll give you a chance to read that. Okay. So after 10 years, we're paying off the mortgage. All right, we're going to sell the home and pay off the mortgage. And what we want to do is we want to figure out how much of the principal, how much of the original loan is still owing on the house. Okay, so what do we think? So first of all, just loosely speaking, without any math, how much principal is left on the house? Like, how do we actually compute that? So you can see here that there are a bunch of computations. It looks like I've set it up using some sort of annuity formula, but what am I actually computing when I want to compute the principal? Like use the words future value, present value, things like that. I think we actually talked about this on Thursday, right? It's the present value, exactly, Jeremiah. It's the present value of what, though? Because we're 10 years in, right? We have a 30-year mortgage. We're 10 years in, and we need to figure out the principal, not at the beginning of the loan, but the principal after 10 years of the loan. So it's the present value of what? The present value of the mortgage with 240 months left. Absolutely. So it's, or if we want to say that a different way, Owen, but you're absolutely correct. We could say that it is the present value of the remaining payments, right? Of the 240 months of the remaining payments, right? Absolutely. So this annuity formula here is trying to compute the present value of the remaining 240 payments. What should the exponent be? And after 10, wait a second, your monthly, yeah. But so Jeremiah, none is the correct answer, but what is the correct answer? Right, oh, and exactly, negative 240. Okay, does everyone see why? There's 240 months left. So the present value is going to be either positive 240 or negative 240. Because it's a present value, the exponent is negative. Okay? This is the only none of the above. Yeah. Okay, everyone's good? Okay, perfect. And then So let me stop the share here. Oh my God, so much noise outside my window. And then Kurti, you gave me those tutorial questions. Which question? Number 2. Suppose R greater than 0. I guess I should share my screen again so that not everybody needs to try and download it. There we go. So number 2 is this question. Suppose R greater than 0 describes an interest rate. Sorry, I'm just going to close my window a bit. And compounding interest is made according to the following scheme. After the first month, R, after the third month, R, and after this, the cycle begins again. If a perpetuity of R dollars is paid out every 6 months, use the above compounding interest scheme. What is the present value of the perpetuity? Actually, this is the exact question we just did. This is 2-57 because it's 2-57, but instead of compounding twice per payment, yeah, how many times do we compound per payment, everyone? So instead of twice, it's well, let's be careful. So first month, right, we do every 6 months. So we withdraw on first month, third month, fourth month, and 6th month, right? So there are actually 4 compounding periods per payment. Does that make sense? Right? So it's the exact same question, but when you draw the timeline now, you'll have 4 compounding periods instead of 3, or instead of 2 that we had when we did the last question. It's still worthwhile to go through. You'll get almost the exact same answer. It's just everywhere you had, the 2, you'll have now a 4, and that sort of thing. It's still a great exercise, but it's basically the same thing. Why there are 4 periods? Sure. So let me. This one might help to see visually. So let's share. Let's go back here. And so per that thing, so we had a compounding interest rate of R% in month 1 and 3, and then we repeat, right? And we were told that we withdraw every 6 months. Okay, so if we timeline this, I'm going to draw my periods really large. Okay, so and actually, you know what? Maybe let me do the subperiods. So 1, 2, 3, 4, 5, 6. Okay, right. So month 1, 2, 3, 4, 5, 6, and we're going to take out interest after the first month. So R, and after the third month, right? And then the cycle repeats again. So we then do it after the 4th month and after the 6th month. All right, and then we just keep repeating the cycle. So we would get R, 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 R like this. And so if we look at any compounding period kind of in isolation, right, we get 4 compounding periods. Though again, notice that first payment, when we bring it back, will actually start at 1 plus R to the -3. And then -7, -11, so on and so forth, right? It'll change by 4 every time. I only did the first month. Yeah, exactly. Because you only did the first month, and that's why you only got 3. Yeah. But then after that, it increases by 4. And the reason that first month is so weird is because the payment occurs at the same time as the 4th compounding event. And for that reason, it doesn't actually see that compounding event, right? But if we said that the payment was made at the beginning of the 6th month and was made at the end of the 6th month, then P would actually pick up that 4th compounding period. But in this case, because they're kind of made simultaneously, then it doesn't actually see it. Okay, so is that good? Everyone's okay with that? Are there any other questions on that one? Or I guess at this point, any other questions, period? Yeah, these are great questions. And again, I recommend that you don't hesitate to try and improvise on these. And instead of doing like R in the first month and R in the third month, what if you changed it to R in the first month and S in the third month, right? And how does that change the problem? And can you redo the problem in that scenario? And if you can, like I said, you're golden. There's nothing that I could throw at you that you couldn't do, right? So yeah, you'd be, right? Just don't hesitate to throw yourself curveballs and see if you can hit them. Okay, anyone else? Anything else? God, there's got to be stuff out there. Y'all, I mean, if not, that's phenomenal, because I'll assume that means that like everyone feels very confident. But, with the test, I figured I was going to get just crushed this week. I think everyone is waiting for someone else to ask a question. Okay, by the way, a nice kind of change up for this question as well is say, okay, now what if we change the payments, right? So a nice change up to this, maybe I'll do this if you all want a question. This is a really nice sort of thing to take up. Okay, so let's do this question, but let's change it. And let's say instead of the first payment happening in week or at the end of month 6, the first payment happens at the end of month, what is that, month 4, but then still repeats every 6 months. Okay, so what I've done now is instead of occurring at the end of the 6th month, like we had originally, I said it's at the end of the 4th month and then repeats every 6 months, right? So this is a little bit weirder, but it's not too crazy. So I'm going to put the payment P there, and then R here. We skip a month, we do that, and no, what am I doing? 1, 2, 3, 4, 5. Well, that's why, because there's seven weeks in this month. Or in this 6th month period. That's obviously not good. Okay, there we go. So 13, 14, 15, 16, 17, 18 month, that makes more sense. So R like that. So do you see what I've done to change this? Does this make sense? So I've said now the first payment occurs at the end of week 4. But then after, yes, the first payment occurs at the end of month 4 and then repeats every 6 months. How do we do it now? What's the first payment? Careful, again, if it coincides with the interest, we don't count that interest. Right, in this case, it's -2, right? So you're doing the right things, Jeremiah. You just, when they occur at the same time, you don't pick it up. If I said at the beginning, and here's kind of a technical thing. If I had said the payment occurs at the beginning of month 5, it would have picked up that 3rd payment. And so in that case, you would be right, if that makes sense, right? Because the difference is whether R and P happen at exactly the same time. So if they happen at exactly the same time, that payment doesn't get R. But if I'd said, oh, P actually happens here, then when I bring it back, it actually goes through that R, right? And then in that case, it would actually pick that up. Does that make sense? So if they happen at exactly the same time, the payment doesn't see it, but if the payment happens just even a couple of minutes afterwards, it would see it. Okay, what about this one? Exactly. Curdy, I feel like you had that one primed up, like you typed it out ahead of time because you knew it was coming, which is awesome. That's great. Okay, and this one? Right, exactly. 1 plus r to the negative 10. And what we see is we still get this pattern. The common ratio is still 1 plus r to the negative 4, right? That's never going to change. The only thing that changed is what the first payment was, and therefore it did change all the exponents, but the difference between each set of payments is still negative 4, right? That doesn't change. It only changes, it just kind of shifts everything over by one exponent. Yes, exactly. If I don't, so Jeremiah, this is kind of like, again, this is based off of an old way of us doing it, where we used to talk about payments and the interest and the compounding interest rate being simultaneous. If they're simultaneous, then it does not pick it up, right? That payment does not pick up the interest rate. But as of this year, we've been very clear about it, right? And we'll usually say, it compounds at the end of the month and the payment is the beginning of the month. And then that way you can actually see whether it pushes through or not, right? So we've tried to not use simultaneous events and tried to have them offset by at least a day or so that it's crystal clear about, whether you pick up that event or not, right? And yeah, Curdy, exactly. Common ratio is negative 4, right? Because we can see how much is that exponent changing by every time. It's negative 4. So if we write this down, exactly. So we're going to get, so the present value is this. And as Curdy says, this is negative 1, the common ratio is negative 4. So I'm going to write this as the sum. Now the first term, right, is p times 1 plus r to the negative 2. The common ratio is negative 4. So the first value of k is 0, very good. And then it goes to infinity. Again, I'm just going to factor this portion out. And then I can use my formula, right? P times 1 plus r to the negative 2, 1 plus r to the negative 4, like that. Right, so you see, it's the same sort of thing every time. And once you've done enough of these, you kind of like really get into the habit of doing it. And this is kind of, I think, a curveball we haven't thrown at you yet, where instead of changing the interest scheme, we actually change where the payments occur. But again, don't freak out, don't panic, right? Just go back and you know how to deal with this. If the payments move, just start from scratch and set it up again, right? So you don't freak out. How do you know this is infinity? Because so if I recall correctly, the problem actually says perpetuity, right? And perpetuity means goes forever, right? Like perpetual. Yeah. So it explicitly said perpetuity, I think, in the original problem. You might have to double check. I'm pretty sure it said perpetuity, but yeah, it does. So that's how you know, right? So an annuity stops eventually, it's finite. Perpetuity goes forever. Right. Yeah. Yeah. If it says annuity, it specifically has a fixed length of time. Perpetuity means that it goes forever. Yeah. Right. And again, in practice, there's no such thing as a real perpetuity, but you can model things as if they were perpetuities, right? Amortization is, I want to be careful saying that it's always present value, because again, there could be some situations where I contrive of a question where it's not present value. But if you're being asked for the value of the loan at any given time, that is the present value of the loan. And I think that's kind of the more important thing to take away, is that the value of a loan is the present value of its remaining payments, right? That's the thing to remember. Sure. I mean, it kind of depends. Yeah, you'll have to find me one. Like, let me think. Sure. Let's use this example again. So we still have this timeline, and I'll just copy what I can of it. So we're going to use this example. Oops, did I actually hit the right button? No, that's copy. Okay. That's paste. Sweet. Okay, so same example, but maybe again, let me make my payments like P occur at their normal times. Okay, so let's say, and let's actually do a two-year loan. So let me just write in the extra couple of months. And compounding events. Okay, and then our final payment right here. So 21, 22, 23, 24. So let's say we do the following question. You take out a loan for, I don't know, let's call it S dollars, or let's call it L dollars, right, for loan. Amortized over 2 years. And according to this crazy scheme above, right? Above, what are your semi-annual payments? And remember, each P is semi-annual, right? It's 6 months. That's what semi-annual means. So each of these P's is one of your loan payments. What are your semi-annual payments? Okay. So what do I do? L is P times, yes, for stuff, right? And take it back in time, find the present value. Okay, right. So let's find the present value. And I think, Ariana, that's what you're saying, right? Is that like the value of the loan is P times whatever that junk is. And you just didn't want to write out all that junk. And Curdy, you're kind of saying, what is that junk? Well, let's find its present value, right? Okay, so let's pull all this stuff back. So the present value of the loan is that we're going to get L is equal to, and we've already kind of done this, right? 1 plus R to the negative 3, 1 plus R to the negative 7, P times 1 plus R negative 11, and P times 1 plus R to the negative 15, right? And I can, yeah, exactly, Curdy. Sorry, I kind of went a little bit faster because we had done this one a little bit before, right? Because I'm just kind of repeating what I did. Oh, I think I erased it. Did I erase it? Yeah, I erased it, but we'd already done some of this, right? So I was doing this one a little bit slower. I wasn't trying to like steal your thunder or anything. And, you know, we can factor this P out. And again, you can use a sigma notation here if you want, or you can choose not to. It doesn't matter. This one is short enough, you don't have to. It's only got the 4 terms, but oh no, we factored a P out. That shouldn't be in there. But if you had like 200 payments, then you'd probably want to, use the sigma notation. And then we can just solve for P by dividing, right? L divided by that chunk right there, which I don't want to all write out again. Amortized means paying off a loan, Jeremiah. So usually it says, if I say it's amortized over 2 years, it means that's how long I'm going to pay it off over, right? So mortgages are usually amortized over 25 years or amortized over 30 years. And so that means that that is the amount of period over which the loan will be paid back. Okay. Mm-hmm. Yeah, Ariana. And then what are your Ks? So if I wanted to write this as sigma notation, so you're saying do 1 plus R to the -3 minus 4K as K goes from, what's the first one? 0, very good. Okay, and what's the last one? Ooh, you probably don't want K is equal to 14, right? Because that would be a really big number. 3, right? Because what you're asking is -3 minus 4K, right? That's the exponent. That has to be this one, so that has to be -15. And if you were to solve for this, you get -4K is equal to -12. So K is equal to 3, right? And then that's how you could do it. P is the semi-annual payment. Yeah. So I mean, I didn't write it down super clearly, but each of these is a month. So semi-annual means every 6 months. And you can see that the payments are happening at the end of every 6 months, right? So in this case, that's, what the timeline is actually setting up for you. Okay, so yeah, exactly. And if we wanted to write it as sigma notation, we'd write it like that. And I don't think that's worth plugging into the formula for a finite geometric series. In this case, there's only 4 terms. Again, if there are a lot of terms, go ahead, plug it into the formula for a finite geometric series. In this case, I don't think it's worth it, right? Just kind of compute what those numbers are from scratch if I gave you actual numbers. Otherwise, just kind of leave it the way it is. And then a different question would be, you sold after 1 year, you got rid of the loan, right? And you had to pay it back. So you had to figure out what the principal was. So what value is remaining on the loan after 1 year, right? So after 12 months, so maybe this is like part B, right? So you'd say something like after 12 months, you want to pay off the loan early, right? So instead of making your payments, you're just going to pay it all off. Pay off the loan. What is the value of the loan? And let's say, just for the sake of clarity here, because there could be some ambiguity, let's say for the sake of clarity, you've already made, we're standing here, okay? So we've already made these payments. So these payments, we're not worried about it, okay? So in the timeline, I'm asking you, right? Let me maybe zoom out so y'all can see it. I'm saying we finished the second payment. So we're now at the beginning of the second year. And I'm saying, okay, I now want to actually just figure out what the value of the loan is, how much of the principal is remaining. So what do I now need to compute? Present value of the rest of the payments? Absolutely. Based off of the timeline that's remaining, what is the answer? Perfect, perfect. Curdy, you mean don't forget your plus, but yeah, right? And remember to add them, right? You don't want to multiply them. Is that okay? Do you see? Right, okay. Exactly, there you go. So that's the value of the loan. Now, if I wanted to make this, and I kind of am sad that we don't have another assignment, because what I would ask you now as part 3 is I'd say, okay, you now refinance the loan using a different interest scheme. Figure out your payments then, right? So what I do is now create a new interest scheme. Maybe it's like R% every single month. And I would say, figure out now what the monthly payments are or something along those lines. Okay. Tina, did you mean to unmute? Because if you did, cool. But if you didn't, I don't want you to accidentally, yeah. You don't want to just accidentally get caught, getting hurt. Okay. Anything else? Does that make sense? And again, if you all want extra questions to do, seriously, I'm not even joking, go find questions that we've already done and change them around, right? Add in new interest schemes, change the interest, change the payment frequency, change the period, solve it, and then give it to a friend and ask a friend to solve it as well and compare your answers and see which answer is right. And doing this, you can create a nearly infinite number of solutions. And if you and your friend answer the question separately and you come to the same answer, chances are it's the right answer, right? Or you have exactly the same conceptual misunderstanding. But chances are more than likely that you actually have the right answer. So make your own problems, solve them separately, compare your answers at the end. If your answers are the same, you're probably right. Right? So again, an infinite supply of free practice questions. And so as a sort of study thing, this is a nice, nice thing to do. Okay, I want to emphasize to everyone just the following little thing. By the time you're ready to study, by the time you're ready to write this test, you will be in your prime, right? In terms of your knowledge of financial mathematics. And you might say, like, I know this stuff so well right now, there's no way I'm ever going to forget it, right? Because you'll have studied so hard and you'll understand things hopefully so well that you're like, yes, I got it. And I can't emphasize enough that no, you will have forgotten that by the time April comes around, right? And you have to write the final exam. So after you're done the final, maybe during reading week or, whenever you finish, once you're done the test, maybe during the reading week or, once you submit it, what you should do is write yourself a little training document, okay? And I sometimes say it's like a letter to yourself, but it's not quite that dumb sounding. Basically, when I would write this to myself, I would say, okay, these are the core concepts, and this is how I understand them. These are the things that I got stuck on, and this is how I got over them. Here are the examples that I thought were really interesting and really good, and that. So basically what I want you to do is pretend as though you were teaching yourself from 3 weeks ago, right? The 3 weeks ago, you who had no idea how to do any of this stuff, but now you're a pro. If you had to explain it to yourself, what would you say? Because listen, as good as I am at explaining stuff to you, nobody is going to be better at explaining stuff to you than you are, right? So what you need to do is you need to write that down and then put it away in a safe place. And then what's going to happen is in April, when we come time to write the final exam, I promise you, you have forgotten everything. And what you don't want to have to do is have to relearn it again from scratch. That's a nightmare. So what you're going to do then is you're going to open up that piece of paper or that document, wherever you put it, and you're going to read this letter to yourself. And I promise you, if you have to relearn it from scratch, this is going to take you hours to do. If you reread that letter, you'll have it in like an hour, right? You'll read that letter, you'll do a couple of exercises, and like in an hour, you'll have everything back to where you are right now, okay? But if you don't write yourself that letter, then come April, you're going to have to relearn all this stuff from scratch, and it's going to take you 5 or 6 hours, right? And you don't want to do that. So I know it sounds kind of stupid, and I know it takes a little bit of time to do, but future you will be very happy if you do it. And if you don't do it, future you will be very angry at current you. So, you just have to decide whether or not you care about future you. Nice, Jack. That's perfect. Yeah, that's awesome. Yeah, that's good that you did that. And you should do that for everything. And I mean, that's not just math class. That's really kind of any class. There are even times when, one of the things that I think screws up a lot of students is they get into third year. I don't know if this is true for other fields, but it's definitely true of mathematics. And I'm teaching a third year class now, and my students are getting burned on this. There's a bunch of stuff that they learned in first year that they assumed that once they left first year, they would never need to know it again, right? And so now in like a third year class, we're like, yeah, you should know this from first year. This is all obvious stuff that you did in first year. And they're like, yeah, I learned it, but I don't remember any of it. And so what writing that letter nicely does too is in a couple of years from now, if you ever need to come back and remember this stuff for whatever reason, like maybe you'll never need it again, but in the event that you ever do, again, you can just read that letter, go through it, and pick it up again really, really quickly, which is a nice thing to do, rather than trying to learn from scratch something that you learned 3 years ago just by going through your notes, right? Instead, write it in your own words to yourself, and you'll be able to pick it up really, really quickly, right? It's a worthwhile thing to do in every subject, every chapter of every subject. It is definitely worth doing. Okay, everyone, I think I don't see any more questions forthcoming, and I think we're at the end of office hours here. So if there's anything quick, throw it out. But otherwise, I think we can call it quits. And of course, I'm sure there will be more questions by Thursday as people kind of start buckling down for the test, right? And so again, I'll be happy to hang around on Thursday. You can throw stuff on Piazza as well. I'm happy to answer questions there. But yeah, thanks everyone. Have a good Wednesday. Study hard. And I will see you on Thursday. Bye, everyone.